Okay, good morning, everyone, or good evening if you're outside of Doha. My name is Professor Ali Galambor, Program Manager with QNRF, and I would like to welcome everyone to this ROS Research Outcome Seminar of QNRF. And so we have a full agenda, but we're not going to keep you too long, probably just a little over 2 hours or so that we have planned. Really a very full-packed and exciting program on air quality issues. So I have a very quick introduction to this seminar and so the QNRF Research Outcomes Seminars, this is really an outreach program from QNRF to disseminate some of the research outcomes that the QNRF funds, and hopefully they are relevant, to the stakeholders and to showcase, some of the fruits of the are really very good researchers, here in Qatar and around the world, that they have done a lot of work, in from the funded research that QNRF has provided. So that's the purpose of the Research Outcome Seminar, or ROS. And in this case, we have this ROS on air quality, and we have research outcome seminars on various topics, and in order to just kind of keep some kind of a focus every so often, we pick a particular topic, and we have these such events. So on this occasion, we have this air quality, and as you know, air quality is not really confined, to a particular space. We have air quality of issues because of transportations, because of building, because of industry, agriculture in the cities, and natural environment. And so the idea here is that to kind of take a look at some of what has been done in the last several years, with some of the research in some of these areas. Of course, we cannot cover everything, but nonetheless. So as again, that some of these issues, are really widespread, in the environment and even in the classroom, in the schools, and in the cities. And so we have funded at QNRF many projects, and our flagship program, the NPRP, National Priority Research Program, we have funded about more than 20 projects, around about $19 million, and of course some of the other programs such as the undergraduate research program, the graduate research program, some of the early starter faculty member research program, and also the workshops that that we hold. So we have had a few on some of the air quality issues. So we have had really over $20 million in funding on this particular issue, and that's really at the minimum, because we have many other projects that they have some air quality component, but they're not entirely related to air quality. So today, we have several distinguished speakers, from Ministry of Environment, from Qatar Gas, from Qatar University, Texas A&M. And so hopefully, if we don't have any technical issues, they're supposed to be in that order. And so we will show you about actually 7 presentation two kind of a keynote presentation to kind of give you a general overview, and then we have 5 funded project presentation so that they can give you just a nutshell of what they have done, and then we have a question and answer Q&A session at the very end. So we're just going to let the speakers talk, and then after they finish, once we finish with all of them, then there is a chat box, that urge you to place your questions or comments, and then we'll try to get to those as many as we can. So with that, I just wanted to again acknowledge the contribution of all of our speakers today, and also our QNRF team really has worked very hard, to organize this. Sheikh Abdullah, Mr. Weil, and Ms. Nadia in the background, always very helpful. And I want to thank, Qatar Gas, the Ministry of Municipality and Environment, Texas A&M, and Qatar University for allowing, the speakers to participate. So with that, thank you very much for participating. And so I'm done with that. So we just go now to our first speaker is Dr. Ahmed Aksasol. He had some difficulty to get online, so I don't know. Is he on now? I don't think so.
No, still unavailable at this time.
Okay, fine. So we will try to get back to him. He's on the schedule to be the first speaker, but he had some technical issues. So we will go to Ms. Sarah at this point. Sarah Alcott, and Sarah is currently working as an environmental lead in Qatar Gas, and she has been around the industry for about 9-10 years, experience in environmental field, specializing in air quality, wastewater management, and environmental compliance. Sarah has a bachelor degree from Texas A&M. I'm sorry, a bachelor degree in energy and environment from University of Leeds, and a master's degree in chemical engineering from Texas A&M in Qatar. So with that, I'll turn it over to Ms. Sarah to start her presentation. Thank you.
Good morning, all. Thank you, Dr. Ali, for the introduction. Can you hear me? Because I've got a message that I'm mute.
You're okay. We can hear you.
Perfect. Perfect. So good morning, all. Assalamu alaikum. In this presentation, I'll be taking you through the various air quality initiatives that Qatar Gas implemented to mitigate its air emissions. To start off, I'd like to give you a quick overview of Qatar Gas. We operate the world's largest LNG facility. Our plants are located in Ras Laffan Industrial City. We operate 14 liquefied natural gas trains with a total annual production of 77 million tons. In addition to LNG, we also operate 2 sales gas facilities, 2 condensate refineries, helium facilities, sulfur facilities, and also terminal facilities to ship our products. Because of our scale and magnitude, air quality is a particular focus area for us. Our emissions can be classified as criteria air contaminants, which are the contaminants that impact human health and the environment, and greenhouse gases. There are 6 main criteria air contaminants: nitrogen oxides, sulfur dioxide, carbon monoxide, particulate matter, and ozone, which is formed by the reaction of volatile organic compounds along with NOx in the presence of sunlight. And because of the nature of our operations, we are focusing on managing and reducing NOx, SO2, and VOCs. As for the greenhouse gases, our emission profile contains carbon dioxide, methane, and nitrous oxides, and we focus on reducing carbon dioxide and methane. I will now take you through our initiatives to mitigate and manage our air emissions, starting off with NOx. We have implemented 3 combustion control technologies to reduce our NOx emissions. We have implemented dry-low NOx in our turbines and low NOx burners in our utility boilers. These 2 technologies have the same principle, which work on controlling fuel and air mix prior to combustion to create a uniform flame and therefore reduce NOx emissions. And flue gas recirculation. Flue gas recirculation is applied to our boilers, where flue gases from the boiler exhaust is recirculated back to the main combustion chamber. This reduces the peak flame temperature and also lowers the percentage of oxygen in the combustion air. Based on our significant investment in these technologies, we have reduced our NOx emissions by 85% since 2008. I will now explain how we have reduced our fugitive volatile organic compounds. So we have done that by implementing a leak detection and repair program, which is in line with US EPA standards. We use an infrared camera to detect the leaks. The camera is the image in the middle. This camera allows us to cover a wide area in a short time. We also use a thermal vapor analyzer, which is on the left. This analyzer measures the concentration of the leaking gas. Annually, we monitor over 125,000 equipment components. This program helped us reduce our fugitive volatile organic compound emissions by 90%. I'll now move on to talk about our SO2 emissions. The main source of our SO2 emissions is from the sulfur recovery units, and that contributes towards 83% of the total emissions, followed by the flare stacks. Flaring contributes to 10% of our emissions, while combustion contributes towards 7%. We have implemented a number of initiatives to reduce our SO2 emissions, which include progressively improving the design recovery efficiencies of our sulfur recovery units. We have implemented a plant-wide acid gas flare minimization program. And as part of that, we use train interconnections during SRU downtime to reduce the acid gas flaring. We have also enhanced our SRU capacity, and we continuously work on improving our plant reliability. Okay, now I'll move on to talk about our greenhouse gas emissions. We have 3 main sources of direct greenhouse gas emissions. The biggest source is combustion, which contributes towards 80% of the greenhouse gas emissions. 15% of our emissions is from inherent CO2. What this means is the CO2 that comes along with the feed gas. So it's naturally present in our feed gas. And only 5% is from our flaring. We have successfully reduced our greenhouse gas emissions by 4 million tons per annum, and that's due to various projects. For example, we have completed a jetty boil-off gas flare reduction project where we invested around $1 billion. This helped reduce our jetty flaring by 90%. We have multiple flare reduction projects. We've also made many operational improvements. We have also reduced flaring during turnarounds. And we have a dedicated carbon capture and storage facility with the capacity to inject 2.2 million tons of CO2 per year. And in the future, we will expand, inshallah, this capacity to 5 million tons per year in the next 5 years. Based on all these projects and initiatives, and many more, we were able to reduce our greenhouse gas emissions by 12% compared to 2012 levels. In conclusion, I'd just like to highlight that the control and mitigation of air emissions is a significant focus area for Qatar Gas. We have invested significantly to reduce our air emission footprint through a range of best practices and emission control technologies. And going forward, we will study further reduction opportunities, particularly relating to greenhouse gases and SO2, and we'll also look into optimizing our flare performance even more. Thank you.
Okay. Thank you very much, Sarah. Good job. Appreciate it. A very informative presentation, good information. So I don't know still whether we have issues with the Dr. Axisol. I think he's still not online. Am I correct? Sheikh Abdullah? Okay. Is Dr. Axisol online yet? No.
No.
No. What about Dr. Farid Twati? Is he?
No. No.
No. Okay, then. So I think they're just having technical difficulty. Apologies for that. So we go to Dr. Konstantinos Kokosimos from Texas A&M. So Dr. Costa, you're available. And Dr. Costa is a professor of chemical engineering at the Texas A&M University, a very distinguished researcher, very active. So I give him and he's widely published, of course, in the area of various areas of environmental issues, especially, air quality. So I'll give you the floor, Dr. Costa, please.
Thank you, Dr. Galambor. My audio is okay, right? Hopefully.
Perfect. Yes.
Thank you for the kind invitation and introduction. Good morning, everyone. In the next few minutes, I will try to convince you that even a simple NPIP project can contribute with the new knowledge and to the well-being of a society, and especially for future generations. Now, in order to do this properly, I would like to share with you our motivation, the state of the art, in other words, what we know, what we don't know, and what we're looking for. And I will continue with a very brief description of our activities and results, and close with the impact of this project. We are all familiar with the haze caused from particulate matter when they reduce visibility and give the atmosphere an opalescent appearance. Furthermore, there is a close quantitative relationship between exposure to high concentration of small particulates and increased mortality or morbidity, both daily and over time. Conversely, when concentrations of small and fine particulates are reduced, related mortality will also go down, presuming other factors remain the same. This allows policymakers to project the population health improvements what could be expected if particulate air pollution is reduced. Therefore, the World Health Organization 25th guideline limits aim to achieve the lowest concentrations of particulate matter possible. There is a good evidence of the effects of short-term exposure to coarse particulate matter on respiratory health, but for mortality, and especially as a consequence of the long-term exposure, the fine particulates, what we call PM2.5, is a stronger risk factor than the coarse part of them. Small particulate pollution has health impacts even at very low concentrations, while susceptible groups with pre-existing lung or heart disease, as well as elderly people and children, are particularly vulnerable. There is no evidence of a safe level of exposure or a threshold below which no adverse health effects occur. The exposure is ubiquitous and involuntary, increasing the significance of this determinant of health. At present, at population level, there is not enough evidence to identify differences in the effects of particles with different chemical compositions or from emanating from various sources. It should be noted, however, that the evidence for the hazardous nature of combustion-related particulate matter is more consistent than that of particulate matter from other sources. In brief, we know that size and composition of particulate matters, and in arid areas like Qatar and Middle East in general, concentration levels are very high, enough to require further investigation. There is a belief in the public that natural particles, in other words, dust, are harmless. A few years ago, a European project studied the effects of fine and coarse particles on daily mortality and emergency hospitalization in 14 European cities in the Mediterranean area, with emphasis on the Saharan dust particles, extremely relevant to us. Scientists collected data for up to 7 years and estimated that there's almost 1% increase on mortality just per 100 micrograms per cubic meter attributed to Saharan dust. These project results clearly indicated that particles arising from natural events are not harmless and actually gave us the motivation to investigate this further. Where are these particles coming from? Some sources of particulate pollution are simpler than others. Earlier, vehicles' exhaust and combustion of fuels was considered the source of particulate matter. Hiding of solids was also a significant source, but most of the times were located far away from inhabited areas. The picture has changed a lot in the last decades, where an abrasion of tires, brakes, and road pavement is now an equally important source of fugitive particulate matter. At the same time, construction activities move next to the residential areas, with any consequence this might have on local air quality. The next reasonable question is why we have not resolved these issues along with the earlier ones. Note that there had been air quality crises in the past, the smoke in Los Angeles and the acid rain in Norway. Some of them are just textbook information anymore. Concerning particulate matter and fugitive sources, there are things we do not know and tools we do not have. Most of the research work concerned Europe and North America, and the same is true for most of the modeling tools. This does not mean that we cannot find the answers, but more work is required, and this work was conducted in our project. Some of these questions were addressed directly. Air quality research should be about the protection of human health and the environment. For this reason, we follow the holistic approach for an integrated assessment of local and personalized health impact. This infographic presents some of the employed tools and the interconnections. We started with field campaigns dedicated to specific sources such as fugitive particulate matter and traffic. We employed analytical methods to apportion and identify the sources. And finally, we elaborated on empirical and deterministic emission models, the airborne transfer of these stressors, and the exposure of humans to particulate matter. For the sake of time, I will not go into many details, but better scroll over a few examples. These examples will span across three categories: measurements, modeling, and assessment. Measurements were used to quantify sources, and more specifically, how much particulate matter is emitted under given conditions. For example, we conducted such a study for construction sites in Qatar and proposed some of the first ever emission factors from these activities. A similar study was conducted later for traffic emissions and the suspension of dust, practically what we call today road dust. At this point, I'm obliged to acknowledge the support of institutions like Qatar Foundation, Capital Project Development, ASGAL, and of course the people within these institutions. Measurements, and more specifically chemical analysis of the particles, reveal the constituents and components of particles, which support the answers of at least two more questions. First, what is the possible origin of the particles? And second, what are the potential effects to humans and the environment? In our study, with the help of the Ministry of Public Health, we found that significant differences and similarities between indoor and outdoor particles and of particles collected in Qatar and elsewhere. As expected, significant quantities of crustal materials like calcium and aluminum have been identified, but we also verified the presence of large quantities of metals employed in industrial catalytic processes, such as vanadium. Using this data and appropriate numerical methods, we identified the main groups and categories of chemical elements, which in their turn point to specific sources. Particularly, and in that study, 11% came directly from vehicles' exhaust, another 7% from other combustion sources, which could be industry, shipping, and others. Almost 40% was sea salt, which at that point was surprising, but later on made total sense because we were still half a kilometer away from the sea. Finally, more than 30% was resuspension, which represents road dust, construction sites, and some of the natural sources. To this point, I need to highlight that this 30% does not include large dust events. Combining this information with the online measurements per minute and hour, one can extract more information for the temporal profile of sources, practically how they vary across time. In places like Qatar, we spend most of the time inside, and this is why it's important to link the outdoor with the indoor pollution. In this graph, we show one of the examples with the evolution of the fine particulate matter with time during a dust storm event. We were lucky at the same time to capture one of the biggest such events back in April 2015. Concentrations approached very high levels outside and lasted for a few hours. In this specific case, the building protected the occupants, although the concentrations reached around 4 times lower than the outside. The ventilation played a very critical role and actually a dual role. If the ventilation was not running, the concentrations inside the building would have been 10 times lower, means that the ventilation brought in some pollution. But without ventilation, we have taken more than a couple of days to actually clean up the indoor atmosphere. At some point, we had all the information collected and processed. Much more might be there, but using appropriate models, we extracted the scenarios required for policy and decision making. Finally, we can start connecting specific sources with their impact on health. With these tools at hand, there are practically only a few things you cannot investigate. So one may ask, why do you bother with fugitive particulate matter? Well, the answer is in this colorful picture in the middle. It's the only unpublished result yet, but in any case, let me give you an example. The World Health Organization estimates or estimated around 140 micrograms per cubic meter of particulate matter as annual average for Qatar back in 2015. Our study now attributes 30% of this to fugitive particulate matter, with 89% coming from buried land within Qatar. Again, following the methodology from the World Health Organization, the fugitive particulate matters could be responsible for 2% of the deaths reported back in 2015. Going even further, high-resolution analysis supports that the overall impact might be very different in different locations. There are areas with 11 times more impact than what the WHO reports, and areas that have half that much. Again, the point is not on the absolute numbers, but on the relative change. Fugitive particulate matter is not imported pollution. It's something within our reach, something which we can actually prevent and control better. We continue investigating this and more other resources: traffic, noise, solar radiation, industry, nuclear incidents, with help of many collaborators and the generous funding of Qatar National Research Fund and Qatar Foundation. In particular, we are extremely proud for our students that were trained during this project. It's a project that we believe had a very significant impact, with new data and publications that we released, and most importantly, a service to the society and the government. This research directly impacted the national air quality standards, the national emission standards reviewed a few years ago, is now part of the national health strategy and the Qatar National Development Strategy plans, with a team of us preparing reports, white pages, and guidelines for these committees. Hopefully, within the time allotted, I trust you have now a better picture of the challenges, but also the solutions and an impact that one single project can offer, and we continue to do so. Thank you very much for your attention.
Okay, thank you very much, Dr. Costa. A very comprehensive, but yet, brief presentation of your work. So again, we will have some questions for Dr. Costa, later on. So I'm just going to circle back to Dr. Aksasol or Dr. Farid. I think, they're not yet on the line yet. Am I correct, Sheikh Abdullah?
No,
Yeah.
they're not.
Okay, then. So we will move to Dr. Bolland Al-Fuldi. And so while he's getting ready, I'll just make a quick introduction for Dr. Bolland. He's currently a researcher at the aerosol company in Ljubljana, Slovenia, and which is a world leader manufacturer of atmospheric, black carbon monitors. He's a physicist, by education, a biophysicist as well, and received a PhD from Eötvös Loránd University in Budapest, Hungary. He was a senior researcher at the Center for Energy Research of Hungarian Academy for Sciences and other European universities, such as, in Antwerp, Belgium, Birmingham, in UK, and Joint Research Center of European Commission. But when he did this particular research that he's presenting, Dr. Bolland was a assistant professor at Qatar University, where he worked on the project that it was funded by this QNRF and about to present. So at this point, I turn it over to Dr. Bolland, please. We can't hear you.
Good morning, everybody. Thank you, Professor Ali, for the kind introduction, and Dr. Konstantinos for his interesting talk. So my talk is, let's say, a continuation of Dr. Konstantinos' presentation. He mentioned how air pollution important, and he mentioned the health effect and other risk on human health. So our project was about measuring air quality, especially indoor places in Qatar, and okay, so the rationale of our work was that people mostly spend their times indoors, especially in the Gulf area because of the climatic conditions. And air quality in the Gulf region is usually reported among the worst in global context, as Dr. Konstantinos already mentioned. But buildings can, let's say, protect people against the outdoor air pollution, although there are specific indoor sources that can contribute to the indoor air pollution. And vulnerable social groups like children are especially needed to have good air quality. So that's why we conducted our research in schools. So we conducted intensive air quality measurement campaigns twice a year during summer and winter to be able to compare the seasonal variation. And we measured indoor and outdoors the air quality simultaneously. And the indoor air quality was evaluated in the contrast of the outdoor pollution. We did our measurement at 2 locations of the city. The first year measurement campaign was conducted at the international school at south of Doha, plus 5 homes of volunteers. In the second year of the project, we moved to north of Doha to a kindergarten, and again 5 homes of volunteers. And we had the outdoor location, 1 station at the school, and we also monitored the outdoor air pollution at the homes. And also we did on-road sampling when the volunteer was moving, and we were following his daily activity and daily track, and measuring the all pollution exposure during the day. The measured components, it was particulate matter, PM, no, it's a mistake, sorry, so it was PM 2.5, black carbon and ultrafine particles, volatile organic compounds, PAH, aldehydes, also bioaerosols, bacteria and fungi, and we also monitored the CO2 to have an idea about the occupancy of indoor places and the ventilation efficiency. Okay, some examples from the results. So these 2 plots, let's say the main summary of our results. The upper panel shows the PM 2.5 concentrations outdoor and indoor. So on the horizontal axis, we plotted the outdoor concentrations, and on the vertical axis, we plotted the indoor concentrations. So we can see that all the time the outdoor concentrations were higher than indoor, except one cases when there was a case of indoor smoker. So the smoker was able to produce even higher PM concentration indoor than it was outdoor. So please avoid smoking inside. So this plot shows that buildings are really good, let's say, provide good protection against the outdoor air pollution. And these extremely high outdoor concentrations were measured during dust storm events. And you can see that there is no effect on the indoor level. So it means that especially in extreme events, buildings works well as a shelter against particulate pollution. On the other hand, the volatile organic compounds, what are produced mostly indoors, we have a opposite picture. So if you can see on the lower panel, again, horizontal axis shows the outdoor concentration, vertical axis shows the indoor concentration, and now we can see opposite behavior. So we found more higher concentrations indoors than outdoors because of the sources are mostly indoors. So for example, at classrooms, we found that several chemicals, what they are used for cleaning, or the markers, what the teachers are using on the whiteboard, these are the sources emitting these components. While outdoors, the sources are less active, or the volume of the dilution of these components are higher, so that's why we were measuring lower concentrations. So it shows that these kind of pollutions are coming from indoor sources. So the ventilation is extremely important to get rid of this pollution. But it means that we have a, let's say, a contradiction. So if we open the window to get rid of this volatile organic compounds, we let the particulate matter in because the particulate matter concentration is higher outside than inside. So that's why a good ventilation strategy is essential to keep the indoor climate clean. Okay, this plot shows our results more in more depth. So the upper panel shows the PM 2.5 concentrations at 4 places. So the first column shows the outdoor concentrations. The second one, what we measured homes inside. And the third one, the personal monitoring results. And the last one is again, the indoor concentrations at schools. So as I mentioned before, the outdoor concentrations are always higher than indoors, and we found lower concentrations in schools than at homes, mostly due to the most, let's say, more proper ventilation. So we found that, for example, the central air conditioning systems, what was the case at schools, are more efficient to reduce the indoor PM 2.5 concentrations. While at home, people are mostly using the split air conditioning system, what doesn't have this effect. So the split units can't filter the particulate matter efficiently, but the central air conditioning system does. So that's why it's highly recommended to install central systems in the new buildings, because it has this protecting effect against air pollution. And the lower panel shows the daily exposure of a person spending their time home, school, and outside the home. So the blue bars show the exposure that the volunteer received at home. The orange shows the exposure that the volunteer received during school times, and the yellow what he or she received outside. So this figure shows that mostly the exposure happened at home. So that's why it's very important that everybody is aware of the air pollution situation at their homes, and try to make some steps to make it better. Okay, so our more let's say conclusions that the occupant's activity impacts the indoor air quality. This generates mostly volatile organic compounds and ultrafine particles, for example, from cooking. So that's why ventilation is very important, but it can lead the outdoor particulate pollution to enter into the indoor spaces. So that's why a proper ventilation system is needed to reduce the indoor air pollution, and the central air conditioning system is recommended, and also the application of air purifier, because we measured that air purifier can let's say clean the indoor air quality very good with very good efficiency. And conscious behavior is needed from the population to avoid air pollution exposure. What also requires a good public awareness and information system. Just an example, don't open the window when it's really bad air pollution outside. So this is a very, let's say, simple step to keep the indoor air quality better. But of course, you would need information for this. So not people who are not expert in air quality doesn't know what is the situation outside. So we found that some people, for example, leave the window open all night, although the outdoor air pollution concentration is maximal during nighttime. So this way they just polluted their rooms and their bedrooms, what should be avoided. So that's why a good awareness is needed for this. And of course, this work was funded by QNRF, and also we thank the German International School and the Early Childhood Center at Qatar University to support of our research. And this research was, let's say, a collaboration of other centers of Qatar University, the Biomedical Research Center, the Center of Advanced Materials, and the Gas Processing Center, and of course the Central Laboratory Unit of Qatar University. So thank you very much for your kind attention.
Okay, thank you very much, Clint, for a good, excellent presentation. So I think, we still don't have the benefit of the presence of some of our missing speakers. So we move on to.
I'm here, Mr. Rani.
Okay, Doctor. Yes, Dr. Tuati. Yeah, glad to have you. Thank you very much. So we go to Dr. Tuati. Professor Farid Tuati is a professor at Qatar University, and he has nearly quarter of a century experience in sensors, embedded system and industrial electronics, and he is widely published, in papers and books and patents, and he has been the recipient of several QNRF and NSF projects, and editor, member for the Journal of Industrial Electronics and Application, and associate editor of IST Transaction, Biomedical Sciences and Engineering, and IST Transaction of Renewable and Sustainable Energy. So with that, I turn it over to Dr. Professor Farid for his presentation from Qatar University. Dr. Farid, please.
Thank you so much, Dr. Ali, and sorry for the technical issue I'm having. Let me go straight forward to first of all, I would like to thank QNRF, Dr. Ali, and all, and Sheikh Abdullah, and everybody really for arranging such a vital yet really critical topic on air quality and its linkage to health. So I will go straight forward to the agenda of today. Rational approach, results, impact, and very quickly initial market analysis and then acknowledgement. So the issue of pollution really is emerging than ever, and an assessment of 3,000 cities in 2018 revealed that 64% of the cities had pollution levels higher than the guidelines of WHO, the World Health Organization. Also, every city in Africa and Middle East exceeded the guidelines, as well as 99% of South Asian cities and 89% of East Asian cities. So the WHO estimate really revealed that the air pollution will cause around 7 million early deaths in 2020. So really, which shows how critical is the topic. So if you look at the big picture, you see that 9 of 10 people breathe unhealthy air, which means that the air pollution is causing problems, very big problems in terms of premature deaths, strokes, heart attacks, and respiratory diseases. So the air pollution, its linkage to higher and early death rates really is very much established and increased, which has raised the concern of having really legislations and worldwide legislation and the regulatory and economic requirements for monitoring and treating and controlling the pollution level. And one of if we remember, of course, the COP 18, which has been held in Qatar in 2012 about the global warming and air pollution. So what is needed indeed is you need to be able to control air pollution. So there is a pressing need really to adopt a new having of paradigm shift in terms of monitoring and controlling air pollution in urban and industrial areas nationally and regionally and worldwide. So the solution is, the current solution really are like the grey wolf solution and other companies' solution really does not allow to have wide view and the global picture of at urban scale how pollution is being, the stats of the pollution, etc. So really we need to have a smart solution where that can work at urban scale, large scale, really in municipal areas or as well as industrial areas. So our approach was based mainly, of course, as using international standards, right? And customer journey. Of course, we have to look at the pains and gains of our customers, of the end user using current technologies. And it's, you know, it's a trade-off between user requirements and sensor characteristics or system characteristics. Of course, the users are looking for stability, for ruggedness, means the system has to withstand harsh and extreme conditions of environment. Also, the detection limits, some you know, pollutants that are at very low level but still harmful. So we need to go to the ppb, the per billion detection limit and sensitivity. Also, the data quality should be reproducible and reliable. Of course, the last not least, the cost. So we follow that approach to see the pains and gains, and we come up, we design such an invention which really is scalable, energy efficient, low power, and also cost effective, and working really in mesh network topology where you can really monitor wide area, large scale areas. This invention is protected by 2 US patents, right? And is currently working at the TRL7 level. So it complies with the US FTC and the European Community EMC, the electromagnetic compatibility for indoor-outdoor applications. And also it can work also at harsh environment like Qatar or in similar hot, humid condition elsewhere. So of course, the system is really being powered by harvesting energy, as you can see from the environment, using artificial indoor light, solar, using also a vibration, harvesting energy from vibration, using also the thermoelectric generators, the TEG, what you call the TEG, and of course, all these really will make the system autonomous and can be used in a set and forget scenario. So yes, it has the Internet of Things where we can really get your result and mobile application or wherever you want through a server. And also it has, you know, you can also use it by taking a car and go around the city, and the GPS will record the air quality data as well as the position that you can use later on to map, to have a very special monitoring of the pollution. So what we are proposing here as value is the system we are proposing is innovative with all those features. It's effective, it is scalable and rugged, and it has a digital dashboard where you have really, you can see a very special visual, very special air quality index for any region. So the product, of course, as I said, we are at the TRL7 and entering hopefully the TRL8, and it is functional. It's really measuring the most important pollutants that are recommended by WHO, the SOx, NOx, you know, the CO2, CO, the VOC, the volatile organic compounds, the ozone, the particulate matter, and it is scalable, and of course it can work at harsh environment. We deployed the system, of course, in Italy with our collaborators, in Qatar here, in Early Childhood Center of Qatar University, in the also at the greenhouses here, in different labs and offices, as well as in municipality bridge site in Brescia, Italy, and the city train tunnel site. So the system has been tested really in extreme in cold areas, and as well in hot space, harsh environment like Qatar here, and it shows really very good results. So indeed, very quickly, we could really publish many publications here to get 2 US patents, and we carried out also a lot of workshops, as I'm going to show you very quickly. But one of the main outcomes is building capacity. Really, we involved undergrad and graduate students in research in such a topic. And of course, capstone design projects have been carried out on this topic, on the air quality and, you know, monitoring and analysis using, of course, kind of data analytics, machine learning, and so on and so forth. But the most important things that during all these phases, really, we try to develop the entrepreneurial mindset in the students, to have kind of design, you know, thinking, to have kind of innovate, to be innovation ready for the marketplace. And this is really what people are looking for today for new hirings. So this has to be quite in line with what we really with the QND 2030. If you look at that, of course, is to have to support the development of entrepreneurship and innovation capabilities, and this was one of our main outcomes or objectives. So we organized many workshops. We carried out, you know, Qatar Foundation radio interview. We organized 2 workshops about this, where we invited, of course, our main stakeholders: QNRF, Ashghal, QMIC, MME, Lucille project, Smart City projects, and APQ through Kiri. Also, we publicized our results in Array, as you can see, in Qatar University magazine that reached really a wide spectrum of audience. And of course, this project was invited to a practical workshop organized by the CENG, College of Engineering, Qatar University, for innovation and commercialization and innovation of research outcomes. So we carried out very quickly, a kind of an initial market analysis, and the overall environment monitoring market. This is made to grow at a compound annual growth rate of 4.1% to reach like around $17 billion by 2025. So really is very critical, and many drivers are there. Of course, the concern of health, the increase of the environmental detrimental effect on the environment, and so on and so forth. Really, regional and international efforts have been carried out, are stressing the fact really to monitor and to adopt new techniques or new approaches really to limit the pollution and the adverse effect on the ecosystem in general. So of course we carried out a lot of market segments and so on and so forth, and we identified our key main users, and of course we can propose the business model, B2B, business to business, to customer, and so on and so forth. But of course it needs more work on this, and we have potential competitors, and we really, the technology has went through QNRF, thankfully has sent the technology to FUNTech, US FUNTech, to make kind of technology assessment, and we got really very positive results. And one of the Perkman Elmer has shown really interest in adopting the energy harvesting to license the energy harvesting part in our problems. So without just, I would like to I finish. Due to time shortage, of course, I can't go into much details. And I would like to thank QNRF. Last but not least, since the stakes are so high, and there is still a need, we need to continue really, funding high reward, high risk projects, because the biggest risk really is to not take your risk, and to guarantee a failure is to not taking your risk. Thank you so much. I would like to thank all my collaborators, the QNRF and Qatar University for reaching these great results. Thank you so much.
Okay, thank you, Dr. Farid. Again, as a reminder, we have, Q&A at the end of all the presentations. So thank you very much, Professor Farid, for a very informative talk on your project. So I think, we are still not able to connect with Dr. Axelsol, MME, so we'll try to circle back with him again later. But at this point, I would like to go to Dr. Mohammed Nunu. Professor Nunu is a professor of chemical engineering at Texas A&M University. He received a bachelor's degree from Texas A&M University in College Station, US, and MS and PhD from Ohio State University in chemical engineering, and he worked as a consultant in the semiconductor industry in the US, and he was a faculty member at in UAE, and then joined chemical engineering at Texas A&M University in Qatar. And he has, again, a very prolific publication record in journals and book chapters, and also editor of several international journals and conference proceedings. And he's a senior member of American Institute of Chemical Engineers and a senior member of the Institute of Electrical and Electronics Engineer, IEEE. So at this point, I turn it over to Dr. Mohammed Nunu.
Thank you, Dr. Ali, and good morning to all. Can you see my slides?
Yes.
No,
So this
different slides. Mohammed needs to reshare again.
Can you see it now?
Yes.
Yes, we can. Yes. Thank you.
Thank you. So in this presentation, I will highlight the main objectives and some of the outcomes of this project here, enhanced monitoring of environmental and chemical processes. So here's an outline for the presentation. I'm going to talk first about what is process monitoring and why it's important, talk about the project objectives, some of the challenges that we encountered to develop monitoring tools, and the tools that we utilize to overcome these challenges, some of the developed techniques that we developed in this project, and then finally, an example just to show the idea through detection of sensor faults and air quality data. So what is a process monitoring? Process monitoring is the evaluation of process performance to ensure proper operation, just to make sure everything is working normally. And this is done usually by monitoring some key variables. For example, in air quality, some of the air quality variables. In chemical processes, we have, for example, the purity of a product and so on. Process monitoring usually consists of two main steps, fault detection and fault isolation or identification. And this project here will focus on the first one, which is only fault detection. Why process monitoring or fault detection is important here for us is safety is the #1 priority, because in air quality, for example, if you measure air quality data, you want to make sure that you validate the data before you share it to the public, or you want to make sure that everything is working normally. If there's a serious change in air quality conditions, you want to be able to detect that. In chemical processes, of course, we care about stability, about the operations of the operating conditions of the process and so on. And also profitability is an important factor, especially when talking about chemical processes. So what are the project objectives? The main objectives of the projects are to develop data-driven fault detection techniques for improved process monitoring. So we rely on data to develop these techniques. And the second objective is to apply these developed techniques to enhance the operation of chemical and environmental processes. So both the development of the tools and the application of the tools to in real applications. Why we focus here more on data-driven techniques? For multiple reasons. In many cases, physical or fundamental models are not available, especially for complex systems. And also recently, the advancement in sensing and data storage technology allows to collect large amounts of data, and we can also store these data. And these data are very good source of information about whatever the process, environmental or chemical. And if we can make good use of the data here, we can really improve the process operation or the monitoring of it. But using data to develop fault detection technique is not a very simple task. Actually, there are many challenges that encounter this the development of these techniques. Whatever technique has to deal with multivariate data, multiple variables, handle measurements, measurement noise that mask the important features in the data and make it lower quality, detects small and different types of faults. It has to be sensitive enough to do that. It has to handle cross-correlation and autocorrelation, and these things, I don't want to go into detail, but these would hurt whatever model you develop from the data. I need to be able to handle those, and also to be able to handle corrupt data like missing measurements or of this nature. These are, very harsh challenges that we need to encounter. But luckily, there are many tools that can help us deal with these challenges. I'm going to explain some of those very briefly, such as the latent variable regression, example of that, principal component analysis, and also generalized likelihood ratio test, multi-scale representation of data, interval data analysis. All of these are data analysis tools that can help us achieve the sought objective. Briefly, what is PCA? Is an effective multivariate modeling tool that can also be used in fault detection. It extracts most of the variations in the data in a small number of variables, and it can represent whatever data as a prediction and error. And this error here is what's used in fault detection. So you can develop whatever fault detection criteria to detect the fault. And here is one of the famous fault detection indices, which is called Adq Statistic. The advantages of PCA is that it can handle multivariate data. It can deal with cross-correlation, but it has a drawback, which is assumes Gaussian residuals, and the detection statistic here makes this assumption to be able to make provide good performance. Generalized likelihood ratio test is a statistical hypothesis testing method. It's used to decide between different hypotheses, null and alternative. In fault detection, usually we have two hypotheses: either there's fault or there's no fault. The null hypothesis when you have non-faulty conditions, alternative when you have faulty conditions. But advantages of the generalized likelihood ratio test here is that it provides maximum detection probability. So it's very sensitive to different types of faults and also for small types of faults. So here I'm showing here different types of faults that could occur, and there's examples also in air quality data. If you have, for example, data that or a sensor that gives you a measurement, but the sensor gets stuck at some point and it gives you now measurements with a bias, that's a sensor fault that needs to be detected. Also, if you have a change in on the certainty of the sensor, if you have measurements like this, and then suddenly the variations or the increase in variance of the measurement, that's also a fault that needs to be detected. Giller is good in fault detection. It allows detecting small and different types of faults, but also has a drawbacks, which is also used only for one variable or univariate data, and also assumes Gaussian residuals. Multi-scale representation of data is a powerful signal processing tool. It approximates the data or represents the data as a summation of approximations and details. And the advantage of multi-scale representation of data is that these details are closer to Gaussian at different scales, which satisfies the assumptions of most fault detection techniques. And also, it decorrelates the data at multiple scales. So actually, it breaks down the data in a way that makes it easier for whatever fault detection technique to use it effectively. So it's efficient separation. It provides efficient separation of features from noise. It deals with non-Gaussian data and also deals with autocorrelation of the noise. Interval data analysis is also a very important tool because it's a way to represent or quantify uncertainty in the data, and also used to deal with missing data. For example, if you have measurements like this, you can group data in subgroups and represent the data as intervals, min and max. When you do this, if there is a missing sample here within this group, you do not need it actually, because the interval would cover that. Handling these intervals is not easy mathematically. That's why usually we represent this interval data as centers and radii. Centers are just basically the center of the interval, and radii would be the distance from the center to the edge of the interval. Now, we used all of these tools that we just talked about right now, all of these data analysis tools, to develop better fault detection methods. We developed these methods here: PCA-based Giller, multi-scale Giller, and interval PCA Giller. And the idea behind these tools, just to understand the concept, is to integrate the advantages, because every tool here provides a set of advantages, but it has drawbacks. So here what we're trying to do is to combine or integrate all of these advantages to provide better fault detection. So we provide here or develop three methods. I'm going to explain here quickly. PCA-based Giller, and the idea here is to extend Giller to deal with multivariate data. So you have data, you apply PCA, you get the residual. For every variable you apply Giller, you get the maximum because you want to be very sensitive, any fault in any variable to be able to detect it, and then you classify the data either faulty or non-faulty. And it can be used to detect both changes in the mean or variance. So different types of faults can be dealt with here. Multi-scale PCA-based Giller, here's to enhance the advantage of the Giller technique using multi-scale representation. And the idea here is to apply Giller at multiple scales. So you decompose the data and you apply Giller at every scale, and then bring it back, reconstruct the data, and apply PCA Giller again on it. The interval here, we have the data, we aggregate it, we form intervals, we compute the centers and radii, and then we apply the different techniques. The PCA Giller for the mean and the radius. And actually, we found out that this chart here can detect the changes in the mean very well, while this chart here detects the changes in the variance really well. So here I'm just going to show an example of applying these techniques and show the advantages of applying them in practice. So we used real air quality data that we got from online, collected in street in Italy, a busy street over a month period, and we have 12 variables. This is the list here of the variables. And what we did is that we artificially added different types of faults in the data. For example, here we added a sensor bias, a change in the mean in one of the variables, and a different variables at different location, we added a change in the variance just to see if the techniques would be able to detect those. There are different criteria for evaluating the performance of fault detection techniques. There is the detection rate and false alarm rate. The detection rate is the percentage where it's able to detect when there is a fault, and the false alarm rate is the rate when it detects when there is no fault. So this is false alarm. For fair comparison here, what we did is that we tried to fix the false alarm rate at 5%, and we only compare the detection rate to be fair across the different techniques. So here, I'm showing comparison of the different techniques. This is the Q statistic and the multi-scale. These are existing techniques. You can see here the detection rate is not that high, 57 and 32%. The multi-scale improved. The detection rate here is 89 and 42, but still we have very low detection rate for the variance of change. But these are the 3 developed techniques that we developed in this project. And you can see here the improvement that we achieved. We have 94 using the PCA Giller. With multi-scale PCA Giller, we have 96 and 92 for the change in the mean. And you can see here the improvement and the detection of the variance change from 30 to 40 to 70 to 80 to 98%. So there is a huge advantage here when you use these techniques to detect these types of faults. Even though they're not that large faults to detect, but these techniques are able to provide much improvement. So I'm going to skip these figures because they just basically show the results. But in conclusion here, I just want to summarize what we did is that we developed different fault detection techniques that integrate the advantages of several tools to improve the performance of these detection techniques, and we applied these techniques on detecting single faults and air quality data. And actually, in this project here, as you remember in the title, it covers both environmental and chemical processes. So we use those also in chemical applications. But of course, I'm not going to present this because of the scope of this seminar. So in conclusion here, I would like to acknowledge the support of QNRF and also our collaborators, Dr. Hazem Nono and Dr. Nazmul Karim, who passed away last year, and our researchers, Dr. Majdi Mansouri from Texas A&M, and our 2 PhD students, Zayan Sharif and Noor Basha. Thank you very much.
Okay, thank you very much, Dr. Mohammed, for the presentation. So look like, we have Dr. Khalifa online. Am I correct? Yeah, Dr. Ahmed, you're muted. Okay, so let me just introduce Dr. Ahmed. He's an associate professor of economics at Qatar University, and he's also been awarded with several QNRF funded projects and other funded research throughout the Middle East. Dr. Khalifa has published extensively in leading economic journals, and he received his PhD in economics from Colorado State University. And prior to joining Qatar University, he was an assistant professor at Bloomsburg University in Pennsylvania, and also at King Fahd Petroleum University and Minerals in Saudi Arabia. So, with that, I turn it over to Dr. Ahmed, please.
Right. Thank you very much, Dr. Ali. Do you hear me now?
Yes. Thank you.
All right. I shared my screen. Do you see my screen or not yet?
Yes. Yeah. Well, we did, and then we don't now. Yes, it is there now.
All right. So can I start?
Yes, please. Yes, go ahead. Thank you.
All right. First of all, thank you very much, Dr. Ali and Sheikh Abdullah and the QNRF for this excellent opportunity to present our research outcome. And the project that we are presenting today is promoting energy efficiency in Qatar using a cutting-edge knowledge called field experimental evidence. And the team that we have is part from Qatar University, Dr. Foldi before leaving Qatar University, Dr. Cameron from Padova University, Michael Price from University of Alabama, Al-Ubaidali, Dr. Omar Al-Ubaidali from George Mason University, and Shatarji, Anumitro Shatarji from London School of Economics now. He landed after he graduated based on this project. And the rationale behind this project is determining what is the main factors that affect the electricity demand in Qatar So this is the main purpose of this study, and it is to refine the predictive model used by energy policymakers to help them to take the right decision in the right time. More specifically, the goals of this research project are twofold. Number one is to promote energy efficiency in the electricity sector in Qatar. As you know, energy can focus on the electricity sector, the water sector, and transportation sector, and so on. So our focus for this research, or for this project specifically, is the electricity sector determinants. And to estimate a model for energy demand for the state of Qatar that can explain the consumer behavior in Qatar, the residents and the Qatari residents and non-Qatari who stay in Qatar. We focus on three main determinants in this research. After testing several, we find that those are the most important factor in electricity demand in Qatar. Number one, the growth rate of GDP. Number two is the growth rate of population. Number three is the behavioral use and belief of our people in Qatar, foreigners and Qatari as well. And at the same time, we make the scenario-based forecast for electricity demand until 2032. Consequently, if there is an increasing in demand on electricity, the air pollution will go up in general, because we are producing electricity in Qatar based on acceptable fossil fuel, which is the natural gas, which is the main that we have abundant of resources of this fossil fuels in Qatar. At the same time, as all of you know, natural gas is the best in the fossil fuels from the perspective of the clean perspective. So the approaches that we have used 4 complementary approaches, and based on the most recent trend in economics and econometrics. The first one is the Econometrics Approach. We estimate the main determinant of energy efficiency in Qatar based on 2 main elements. Growth rate of GDP, number 2, the population growth. Is everything clear for all of you? So the voice is the slides and everything is okay?
Yes, yes.
Mm-hmm. All right. So the first approach that we used, we call it the error correction model. Based on the left-hand side is the consumption of electricity in Qatar. The right-hand side are the main determinant, including the changes in the consumption of electricity in Qatar, GDP, and the changes. Number 3 is the population growth in Qatar and the changes. After we have estimated this model and this relationship between those determinants, we run the scenario-based forecast and make the changes based on the efficiency factors. So then we convert the energy consumption or electricity consumption into CO2 emission using the conversion rate 0.539 kilogram per kilowatt hour to see the impact on CO2 emissions. This is the first approach. The second approach, we called it Augmented Questionnaire Approach, to dig more in the behavior of our people, to see how they think, how their belief, what is their response for the current energy conservation efforts in Qatar. So there was some questions to ask about this augmented questionnaire. It's a comprehensive questionnaire. We got the IRP approval from Qatar University, and we run it. And the main questions that we are trying to figure from this questionnaire is the following: are individuals systematically biased on their beliefs? So do they believe in something and do something else? So specifically about the technologies that they are using at home. Number 2, do individuals have accurate belief? Their belief accurate in their energy consumption or not, or they are biased? Number 3, how do these biases depend on the level of energy consumption, residence type, nationality? Are they different? Qatari versus non-Qatari, residents of apartments versus residents of villas, and so on. The third approach that we have used is called lab experiment. We collected some residents from Qatar, we invited them, and with some incentives to come to Qatar University lab, and after the online lab experiment for them. And we divided the groups that we have selected into 3 parts. We call that randomized control trial. Part number 1 called treatment number 1, and we offered them the following verses in Quran. بسم الله الرحمن الرحيم يا أيها الذين آمنوا أنفقوا مما رزقناكم من قبل أن يأتي يوم لا بيع فيه ولا خلة ولا شفاعة والكافرون هم الظالمون. This is one of the verses that we have exposed treatment 1 to it. And the second quotation that, or the second national identity that prime that we have presented is to see the response of the people to those and to see what is the most important message that affects their behavior and see what is their response. So the second identity is it's from Sheikh Jassim bin Muhammad Al Thani. It's called the national identity prime that we call. جمعناه من كسب حلال يزكى وخرجناه فيما يرضي الوهاب. It's kind of incentive or a message to those people to see will their behavior will they respond for donation and prefer the others on themselves to see what is the best message that affects their behavior, which one affects their behavior. All right, then the fourth approach, which is the cutting edge knowledge, is about field experimental study. We collected, we focused on 3 areas in Qatar. It's Daphne, number 2, the Pearl, number 3, Al-Wab. And we divided those residents into 3 groups. Inside each area, we divided the residents into 3 groups. Treatment group number 1, we expose them into the following. We expose them to a religious message. بسم الله الرحمن الرحيم يا بني آدم خذوا زينتكم عند كل مسجد وكلوا واشربوا ولا تسرفوا إن الله لا يحب المسرفين. Then we added to this verses, please use electricity wisely. You have the power to conserve. So in this case, we are trying to let the people, hey, we should take care of the conservation in Qatar. This is a message from our Quran. This is treatment group number 1. Treatment group number 2, we expose that to Prince Tamim identity message or prime message. And he says that in the برنامج الترشيد that the energy conservation program is under the patronage of the Emir of Qatar. We tell the people, hey, energy conservation in Qatar is fundamental, and it is underneath His Highness Prince Tamim bin Hamad. Please conserve the electricity or use the electricity wisely. And group number 3 is called the controlled group. So we call that randomized control trial, and those are the 3 that we have done in Qatar. Okay. So what are the key results from those approaches that we have used? First approach is the Econometrics Approach using the scenario-based forecast. We find that as a worst case scenario, if we have a lower level of GDP growth and a lower rate of population growth until 2032, our electricity consumption will be doubled by 2032. If you take a look here from 2017 until 2032, it goes up from 2.1 kilowatt hours in 9 zeros, and until it reaches around 4.5 in 2032 for the groups that we have selected. If we go to the most optimistic scenario, we will be in trouble. We are talking about five times increases in electricity consumption, equivalent for water, because I have a project for water gave us the similar results. From the estimation process, we find the following, is that GDP growth, population growth, and the irrational behavior of the energy consumption in the state of Qatar are playing fundamental roles and have significant impact on energy consumption or electricity consumption. Those are the main three elements that affect the energy consumption in Qatar. All right, based on the lowest level growth rate of GDP, we are talking about 1.5% growth rate of GDP, which is very low. All right, even if we included the current recessions that we are in 2020 now, because we are taking the average during the whole period. And the electricity consumption will double until 2032 in the case of continuation of the current consumption behavior in the electricity sector in Qatar. This is, it's an issue. It means that we need huge investment in different kind of electricity generation in Qatar. Solar energy that they have done, they spent around $10 billion project to produce that, and expansion of the electricity generation through the electricity company in Qatar nowadays. Number three is electricity consumption and CO2 emission can be reduced significantly because we have changed the coefficient of our model and see what will happen if we improve the efficiency in this case. We find that the electricity consumption and CO2 emission can be reduced significantly with a modification of consumer behavior toward energy consumption. This will include different factors like nudges, like behavioral change, like enhancing our residents to use good technology for conservation in both electricity and the second project for water. We have find the following, which is surprising us. And surprising some people overseas as well. We find a strong evidence of the following. Individual behavior is responsible for the growth of energy use in the state of Qatar, and it is supported by the current subsidized policy. We need to think about that deeply. Technically, from the economic point of view, unfortunately, we are producing inside the production possibility frontier. It means a lot in economics. Not on the production possibility frontier. It's inside the production possibility frontier. I don't like to elaborate about this point, but economists can understand this phrase very well. Individuals do not have accurate understanding of their beliefs. They believe in something and do something else. This is what we have approaches from our behavioral approaches that we are using. This has huge implications from the policy perspective, or we can adopt something based on the evidence. We find also the following, which is very important, has a political, economic, and social consequences and applications. Explicit religious primes could be useful in introducing pro-social behavior. We can count on our religion to enhance the behavior of the people. This is number one. Number two, that impress the audience in overseas. Just yesterday, we have a conference in Southern Economic Association. They found that Prince Tamim message has a great impact on anything else in the nationals of Qatar. Again, we expose the people onto two main messages: religious prime message and Prince Tamim sponsorship of the Tarshid program or conservation program. And the third group is controlled group. We find that Prince Tamim sponsorship of this program has a significant impact, especially on Qatari people. And the third point, nudges, intervention induce strong and statistically significant reduction in energy use by 4% on average on the highest consumption group. We have different group for electricity consumption in Qatar. Those groups called high consumption group, who are consuming huge amount of electricity per month. They respond significantly, and their consumption of electricity goes down by 4%. Of course, this 4% will go through a reduction in CO2 emission and a reduction in subsidies that we can use it to reach the production possibility frontier. Recommendations. We find that simple intervention or framing can reduce electricity consumption in the high consumption group and consequently decrease the CO2 emissions and improve the air quality in Qatar. Okay, the project, as I told you, focus on the demand side. And now we are focusing on and more than that in the coming projects. We will focus on the production side and the consumption side or demand side, we call it demand and supply side, to make a zero CO2 emission by 2050, as European are targeting and USA are targeting, China are targeting that by 2060. Number two, which is very important, a scientific approach in the current and the future efforts of Kahroma is essential to measure returns on investment. They invest a huge amount of money for conservation efforts. Right. If they follow the scientific approach in their work, they will reduce the energy consumption. They will save huge amount of money for the state of Qatar. Test which one give the best result. Which message give the best result? Are they doing that in Qatar now? We are trying to encourage them. We met them several times, tell them focus on the evidence-based policy, which is fundamental. So we were in touch with them last 3 years for this purpose. Energy conservation is essential as an integrated approach for conservation, necessarily to have a model for the region. We can be one step ahead relative to the rest of the country in the region to combine behavioral approaches that we have done, technological approach, because behavioral approach can enhance the consumers in Qatar or the residents in Qatar to use the appropriate technology. Qatar did a good job in this part from what we call enforcement law through the tariffs on the green tools that they are coming from outside. They did a great job. Now we need to combine those efforts together: behavioral approach, technological, policy reform, and law enforcement. We need to sit together to have this comprehensive approach. There are different efforts in Qatar. One step here, one step there, and no co-integrated approach to have this solution. Behavioral approach, technological approach, policy reform, and law enforcement. Reframing the current efforts in the Qatar's energy conservation, we need to do something. We need to have a stable institution to continue, because this will save billions of Qatari riyal in Qatar, not as a whole, but per year. I mean it. They can save billions of Qatari riyal per year if they have framing the current electricity and water policy in Qatar. We have some issues because the energy sector is producing inside the production possibility frontier. This in economics means a lot. I don't like to to criticize anything, but I'm trying to convey the message for the policymaker to take one step ahead, to follow the international standards in pricing and so on.
Dr. Ahmed, can you please wrap up?
I will. Reframing requires an evidence-based policy. We need that in Qatar. Benefits, the overall project provides an excellent opportunity for residents of Qatar, undergraduate students, research assistants, PhD students, researchers in general. Public policy, we provided this the conclusion for our people in several meetings for Kahruma, and we will send this work for Ministry of Municipality and Environment in Qatar, because this is connected with the CO2 emission. Publication, we have published is a high impact factor journal, Energy Policy, and we have three more papers under review for reputable journals. We presented the work in Qatar University, London School of Economics, Western Economic Association, Association of Environmental and Resource Economics. We have one PhD thesis at Georgia State University, and he's landed now at London School of Economics based on this project. Acknowledgement of QNRF. Without a doubt, we would not make any progress or exploring this nice cutting edge knowledge without NPRB support, NPRB 9-232-5026 from Qatar National Research Fund. You guys are doing the best, and you are meeting with the highest standard in the world. And thank you very much for giving us this opportunity. Thank you.
Thank you very much, Dr. Ahmed, for the very interesting information and data. And we have, I'm happy to say that Dr. Ahmed with MME has been able to join us. He was supposed to be our first speaker. Now he's going to be our last, because he wanted to keep us perhaps in suspense. But I appreciate him joining. So at this point, I just want to invite him to go ahead and put up his presentation while I'm introducing him. Dr. Ahmed Aksasol, he's with the Ministry of Municipality and Environment, has a PhD in atmospheric science from St. Louis University. And prior to joining MME, Dr. Ahmed was with the NASA Goddard Space Flight Center in Maryland, US. And working with numerical models for and satellite derived data for weather forecasts. And he was also in academia for a while at the Research Institute of King Fahd University of Petroleum and Minerals, and was also work at the Environmental Department of Royal Commission for Jubail and Yanbu. He joined MME several years ago, and as an environmental consultant, and his interests are in studies and research include air pollution and atmospheric dynamics and numerical weather prediction. So with that, I turn it over to Dr. Ahmed, please. So we can see your presentation, but we cannot hear you.
Please unmute yourself, Dr. Ahmed.
Yeah, we cannot hear you. Yeah, just unmute yourself, but your presentation is up.
Okay. Now, good morning, everybody. Sorry about the delay. I hope this delay will not upset much. Now I will continue my presentation regarding the air quality, particularly in
Dr. Ahmed,
our region.
Please put your presentation into full screen, sorry.
Put it in full screen.
Yes. This seminar aims to present a special in-house studies conducted in the MME, actually, entitled An Assessment of Ambient Air Quality in the Greater Doha Area, using air quality index values, which were originally developed by the United States Environmental Protection Agencies. And the main objective of this study is to describe evaluate and assess the ambient air quality conditions from the recently measured 5-year data set, that is from 2014 to end of 2018, from air pollutant concentrations, and adopted their air quality index values as per USEPA procedures. As you know, National Ambient Air Quality Monitoring Network in Qatar includes the stations operated by Ministry of Municipality and Environment, Qatar Petroleum, Qatar Environment and Energy Research Institute, Ministry of Public Health, and finally Hamad International Airport 5 stations. In addition, the Ministry of Environment operates 3 fixed, namely Al Corniche, Qatar University, and Aspire Zone stations in the Greater Doha area. Here is the this map shows the Greater Doha area with respect to also Qatar map. The location of these 3 stations are shown in the right-hand side, and this region is heavily populated. According to the records, over 90% of the people who lives in Qatar resides in this area. And we studied also the wind, all meteorological parameters, particularly wind and temperature. But I'm only showing 1 year of the years. So from the windroll diagrams, we can conclude that the prevailing wind is from northwest direction. That means any pollutants emitted from the source, it will come toward the south or southeast direction. And this temperature profiles also, this is 1 year, recorded in year 2016. The maximum temperatures actually reached as 49.5 degrees Celsius at Aspire Zone monitoring stations. The minimum temperatures are recorded just below 10 degrees Celsius during January time, winter time. And now we will look at all the criteria pollutants, 5 criteria pollutants, and also their index values, sub-index values, and study these index values to define the air quality. These index values show for SO2 is very low due to the fact that the main fuel used in Qatar is natural gas, no sulfur, which has the low sulfur content in it. The sulfur dioxide concentrations measured in or observed in Qatar, actually it is coming from diesel engines like trucks, buses, and heavy machineries. And these engines use 1% of sulfur in it. And this is the diagram showing that we studied the air quality under 6 categories: clean, normal, less than normal, limited pollutant, extremely pollutant. Just like the US EPA style, with the values varying from 0 to 500. So, as you see here, sulfur dioxide concentrations were found during this 5-year period within the clean category. But only few spikes were observed in year 2014 and 2015, where there was a construction activity was going on in the city. The next parameter is nitrogen dioxide, which comes from automobile engines, found in generally clean, sometimes normal categories with the traffic. All these 3 stations recorded similar trend. However, Aspire Zone stations show relatively stable NO2 concentrations compared to Al Corniche monitoring stations and Qatar monitoring stations. And this diagram shows the nitrogen dioxide air quality sub-index values varying. As you see, during the summertime, it is getting higher values, but with the volume of the traffic. The next parameter is ground level ozone. As you know, this is a photochemical secondary pollutant forms due to the photochemical reaction, and it has three precursors, namely oxide of nitrogen, volatile organic compounds, and sunlight. That means the daily mean temperatures should be around 35 and above 35 degrees Celsius to form the ozone. So in this case, this is a summertime pollutant, and it is observed during the summertime. And from our observations show that most of the time it shows it is in the clean category, but sometimes normal and less than normal during the summertime. You can see it from this diagram. In summertime, it is going up. 3 stations values are going up during summertime. And ground level ozone pollutants in Qatar, particularly, is a transboundary problem. It is coming from the northern states and not generated inside Qatar. The next pollutant is carbon monoxide. It shows in a clean category, and this is due to the traffic again. And this is the diagram. It is in clean category for 5 years. The next one is the main one is the air particulate matters. This is actually inhalable air particulate matters, and it has been found out that the main the status of PM10 in the greater Doha area has been found mainly in the normal category of air quality index, with multiple occasions where it appeared to be less than normal category during summertime particularly. In all 5 years, it was observed that the highest air quality sub-index values were found during the summertime. And this is the diagram for 3 stations. It goes, but sometimes it goes and reaches the less than normal category, particularly summertime. There are reasons why this is happening here, because the sand and dust storm events in Qatar are associated with mainly 3 different periodic wind systems: local systems, regional systems, and subtropical jet system. Subtropical jet brings excessive dust from the Saharan desert to eastward and our region particularly. Therefore, the major natural source of air particulates in Qatar due to long-range transport of dust and air particulates from the North African Saharan desert. And several studies have been conducted in this, and several findings, similar findings, is reported in the literature. And we had an episode, particulate episode, inhalable particulate episode or dust episode in year 2015, April 2nd, 2015. On the left side, it shows this is a jet stream showing that air is coming from west to east, okay, bringing toward the Arabian Peninsula, and Qatar is there. So we had this episode event here. After 1 month, you can clearly see on the right side that the jet is gone, air becomes very clear and clean. As you know, when we do the analysis, we have to validate our data with respect to US EPA regulations and instructions. Unusual weather events has to be invalidated, so this data is invalidated in the system. Finally, the summary and conclusions. Studies show that high air particulate concentrations due to different wind regimes and prevailing meteorological conditions in the air in the region, namely subtropical jet, Shamal system, and with frequent local wind system causes the particulate pollution. Observation also showed that nitrogen dioxide concentrations in the greater Doha area is due to traffic emissions, which is less than the annual national standard and even less than daily standards, 40% of the standards. And with the current rail system and bus system, this will reduce dramatically. The ground level ozone concentration, again, this is a summertime pollutants, and it is coming from mostly cross-country pollutant as the ground level, cross-country pollutant from other neighboring countries. This is carbon monoxide concentrations and sub-index values, air quality sub-index values were also found clean category, and no existences of 1 hour or 8 hour is there recorded. Finally, the ambient air quality monitoring results also show that hourly mean concentrations of SO2 as well as it is air quality index values, sub-index values were found quite low and below the Qatar national standards throughout the year, throughout the study period, due to the use of natural gas as the main fuel inside Qatar. Thank you.
Thank you very much, Dr. Ahmed, for a very informative presentation and information. So at this point, we are going to the Q&A session, and so we have about 30 minutes for this session. Hopefully, we can get to some of the questions. Let me see here. One question says that for Qatar Gas, did you measure VOC and let's see, I lost the question. Thank you for the promoting energy efficiency in Qatar. Any recommendation out of the project finding was adopted or implemented by local water utility and relevance? Anyone?
Yes.
Yeah, go ahead.
Yes, in fact, there is an excellent effort from Kahroma in promoting energy conservation, but it's as a random effort. It's not, they are not measuring the impact of each effort that they are doing. They are doing a great job in advertisement and promoting the energy conservation behavior and the right thing and so on. But they need to see what is the returns on each policies that they are adopt. So instead of doing several campaign in the year, they need to focus on one campaign that we have an evidence on that it contribute in reducing the energy consumption in Qatar. But in general, they are doing great job in advertisement, yes.
Okay.
We provided them the best approach, and at the end, it's up to them.
Mm-hmm. Okay, thank you. There is a question for Dr. Nunu. It says on the sensor fault detection technique, from theoretical aspect, looks very promising. The question is that mainly on the impact of the project, how this research is promoting ongoing air quality sensing effort in Qatar, any government, industry, institution to develop and test these techniques.
Well, in the project, we validated the technique that we developed on real data. So we know theoretically that they do work because we simulated on real data. Now we're hoping that we can do this on real data from Qatar. Luckily, we could not get as much data as we hoped during the project to validate those. But I welcome anybody who has data that we can apply these techniques into to provide us this data, because it would be a good opportunity for us to apply this data in practice.
If I can interact with Dr. Nuno, if you don't mind, Dr. Ali.
Let me just also ask you, and then I give you the floor. There is a question also for you, Dr. Farid. It says, will you bring your sensor to the market? Do you have an industrial partner for that? How much will it cost? So go ahead.
Thanks so much. First of all, let me just interact a bit with Dr. Nuno. I think we can provide you with a plethora of data really about air quality monitoring. We've been really measuring that like 5 years plus now. So I think we can collaborate on that a great deal, I would say. Second to the other question about, as I said, really our system or product is at TRL7, and it went through a technology assessment by US Fuel and Tech, and we got very positive results. So really, it's been deployed in Italy, it's been deployed in Qatar, harsh environment, different environments, different climates, and it's been working very, 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 very well. I mean, here what I'm also suggesting really about the commercialization of the product itself. Of course, we are working on that. We get certification, EMC certification from US FSC and the Community European as well. As I said, protected by 2 US patents. But what I'm suggesting here really is to take it to the other level. I mean, to take it to the product level. And that's why I said one of the main things we are working here at Qatar University is to take it to that level, to the commercialization level. I mean, there are great efforts at Qatar University, really, entrepreneurship and innovation and technology transfer office here with Dr. Harab trying to do that, of course, in collaboration with Qatar Foundation. So the system itself is really is scalable, and cost-wise is very cost-effective, really. So it can be deployed over wide area urban scale, and you can collect your data really remotely using just your whatever server. And this probably what's missing in Qatar here, I would say. If we can have a system that really integrates all the stations wirelessly using IoT platform, where you can do a kind of analysis, data analytics and even prediction of air quality in the region, I think that would be great. And I think we can help in this regard a great deal.
Great, thank you. So I have a question for Ms. Sarah with Qatar Gas. Can you briefly describe your CO2 injection facility? Ms. Sarah, if you're available. Are you there? Yeah, can you briefly describe your CO2 injection facility?
Yeah, sure. Our CO2 injection facility has a capacity to inject 2.2 million tons of CO2 per year. Previously, it was a facility used to inject both CO2 and H2S. And
what do you inject? Subsurface or what?
Yeah, into the subsurface.
Mm-hmm.
So. Okay. Before converting it into a CO2 facility, it was both H2S and CO2, like both these gases were injected. And just last year, we converted it to a CO2 injection facility. And inshallah, we'll expand the capacity. We are studying the opportunity to include to include all the trains. Right now, it's only, I believe, 45 trains who are injecting their CO2. And once we enhance the capacity, it will be 5 million tons per year.
Okay, very good. While you have the mic, there is another question for you. Did you measure VOC and TPH and other organic criteria pollutants?
So we do measure our VOC emissions. So the fugitive VOC emissions from the equipment components are measured using our ELDAR program, while the VOC emissions from incomplete combustion is from some sources we take flue gas samples and measure that, and for some sources we use an emission factor.
Very good. So I have a question for Dr. Ahmed with MME. We have two Dr. Ahmed today. So Dr. Ahmed with MME, did you compare your findings to other air quality monitoring station operated by other entities?
Yes, definitely. We are, even though we are having 3 monitoring stations in Qatar, we are also checking our data with the Qatar Petroleum stations, which is 10 stations inside Qatar. So that we did a study, assessment study, and it showed that our concentrations are lower than the QP stations because they are close to industrial sources. So that, as I mentioned in my conclusions, that the air is actually not bad, except particulate matter, which comes from the natural phenomena periodically. So we have to watch those days and take precautions.
Okay, go ahead, Dr. Ahmed, the other Dr. Ahmed.
Yeah, Dr. Ahmed and Dr. Farid, what is the frequency of the data that you are collecting of CO2 emission in Qatar? And is there one unified source to collect them on, to collect the QP, Qatar University, Hamad bin Khalifa University? Are they under one control, or each institution has its station and control everything?
At MME stations, we are not monitoring CO2. We are only monitoring SO2 because CO2 is a greenhouse gas, not a pollutant. So we are not monitoring CO2.
Okay, very good. Okay, so
Dr. Farid?
Yeah, the frequency of measurement of CO2, right, Dr. Ahmed?
CO2, yes.
Yeah, I mean, you know, our system is very flexible, and currently you can adjust it the way you like. I mean, and currently, for example, we are measuring really every 15 minutes, but it's adjustable, you know, and we are popping out, you know, all the data to a ThinkSpeak and you know, IoT platform, UBDots, you know, where we can have all the data for long period, and we can apply data analytics, you know, like machine learning for prediction and for data analysis. Yeah.
Thank you.
Thank you very much. So by the way, I didn't identify, but we have questions that they have come, you know, that I already asked some of them from various parts of the world, you know, in Belgium, in Bangladesh, and, you know, many others. So I appreciate everybody's participation. So there's a question for Dr. Costa. Your findings and publications were based on the data of 2015. How is the major construction project for the World Cup may affect your finding? The same could be after the World Cup. So that's the question, if you have any comments.
Yes, thank you. I actually answered this question also in the Q&A. We conducted field studies in multiple years, starting 2014, and then we reached up to 2017. These are focus studies, so we focus on specific pollutants and sources. So they're not monitoring studies like in the MME or Dr. Farid. And the models we developed can now expand to any other time period, meaning that you can have them focused during intense construction activities, even after the World Cup, where the construction will be far less. What we identified is that the burial land in Qatar, opposite more or less to what Dr. Aksarhal said from MME, is a very big contributor of particulate matter. That's what our findings say. The local air quality is mainly driven by in-Qatar sources than the outside Qatar sources, which are periodic over the seasons.
Okay, very good. Thank you. I'm not really sure who wants to pick on this question, but it says, is there any long-term target for greenhouse gas emissions like net zero by 2030? I don't know if any of you wants to. Go ahead, whoever. Yeah. We can hear you, Dr. Ahmed.
In fact, the initiative taken by QNRF, and nowadays they are trying to adopt several projects to provide the best policies, the best evidence-based policy to reduce CO2 emission. They have a plan for something called carbon capture and storage, and carbon capture and utilization that we have awarded NPR B12C. And I believe Qatar is consistent with the COP18, the United Nations initiative of reducing CO2 emission. However, there is no a specific plan to have zero CO2 emissions. This is a long-term plan, and it needs a research, and we'll be so happy to help in this regard in the coming years. So
okay, so this is for Dr. Bolland. I think you may have answered it in the chat, but for the other audience, just in case, for the indoor air quality, the parameters you measured in the schools, did you try to correlate such results to the health of the kids and their school performance?
No, unfortunately, we didn't have the opportunity to study to conduct health study, and it would require a double NPRP or 3 NPRP because it's really a big research. So now we just focused on the let's say the air quality part. The health issue is it needs a new project.
Okay, so we have a question. Oh, please go ahead, Dr. Farid.
Yeah, just I would like to add to Dr. Bolland. How are you, Dr. Bolland? It's a long time not seen.
Yeah, very good. Thank you very much.
Nice to see you.
Nice to see you.
So really, I think that's the point raised by the Dr. Ahmed, Dr. Ali is very really paramount, I would say, because there is, and we need to carry out, probably we need to drill down, about this issue of linkage of air quality and to health problems, especially respiratory problems. And this has been really, reported quite seriously for high school students. Really, is around more than 30% of the students having really respiratory problems. I think really it's worth really looking at this one through, and I would like to ask and request Qatar Foundation, as usual, to fund such projects.
Very good. So there is a question for Sarah, perhaps. A big portion of the particulate emission is black carbon. Do you measure control black carbon emissions? Do you all do that at Qatar Gas?
Actually, the majority of our fuel is clean natural gas. So that.
Yeah, we lost you. Hello?
Hello?
We lost. Can you repeat what you said? We didn't hear.
Yes. Most of our sources are fired with the sweet natural gas, and this has less particulate matter emissions. Like, it's very, very small, and that's why we don't measure this.
Okay. Go ahead, Dr. Bolland.
Yeah, actually, it was my question, so that's why I would like to add. So I asked this because when I was Qatar and I saw the failures, it's always black smoke is visible. So that's why I asked. And actually, we measured in the city quite high black carbon concentrations, although the fleet composition is mostly gasoline car, not diesel car like in Europe. So that's why I am wondering what could be the source of the black carbon, what is really high compared to international studies.
Okay, very good. I guess there is a comment here, but if anybody wants to make a comment on this comment, would it be possible to make a public awareness session about what should and should not be done? I hope the outcomes can be translated in a public awareness session, or short video can be made public through Ministry of Public Health social media accounts. So I guess, if someone can maybe work with Ministry of Health to do that. Let me see, what else do we have here? There is a question here that it says what parameters used to calculate AQI. So maybe this is for you, Dr. Bolland, or is it Dr. Costa?
Yeah, AQI is calculated. This is an empirical formula developed by US EPA. So there are only one parameter that you have to be careful about, the concentrations of the pollutants. After you get these concentrations from the stations, then you use this formula to calculate the air quality index values with the sub-index values, breakpoints, with the formula. This is empirical statistical formula. So you get the index values, and indexes are varied from 0 to 500 with different categories.
Okay.
And it is internationally accepted and used. This.
Okay. So there is a question, I think, Dr. Costa, kind of takes the time to respond, but again, just in case if other people don't have it, it says that MME air monitoring network data contradicts with recent reports about ambient air quality, for example, World Health Organization report and a recent State of Global Air 2020 report from the Health Institute. What do panelists from this seminar think about these reports about extremely poor air quality in Qatar? How does their research complicate or engage with the results from these reports?
Dr. Ali, if you let me get in first, really, I wanted really to raise this issue. Qatar is being, listed as the higher or the biggest greenhouse gases emitter in the world, and really, even our measurements in line with the MME, Dr. Ahmed and Dr. Bolland and Dr. Really, I'm not saying that at all. Really, I'm wondering from where this is coming. So our measurement at Qatar University, our really advanced system, really showing that we are really in that really normal and under normal. We have no problem in the in those pollutants or greenhouse gases. We are below the safety guidelines as stated by the WHO organization.
No, in fact, this is the way of how people interpret the stat. So unfortunately, they count on something called per capita CO2 emissions per capita, and our number is very small in Qatar. So in this case, if you divide something on a smaller number, so Qatar per capita CO2 will be the highest, which is not fair at all. We might find some other countries has intensive air pollution relative to Qatar, and their rank is better than Qatar. So this is what, and I believe that some policymaker raised this issue for the World Organization about that.
So go ahead, Dr. Ahmed.
The greenhouse gases are not related to the air quality pollutants. The greenhouse gases are not related to the criteria in the WHO guidelines. The WHO guidelines use satellite measurements, which are extremely biased for our locations. But I have to say that our particulate measurements do match the averages they report. I don't know about the air quality index because we don't apply the methodology that MME is using, but the absolute numbers they report, we also measure closer levels on particulate matter. This is the one that we focus.
Very good.
Dr. Ali, I can show you in real time. We are measuring now with our station, and I can show you in real time what we are getting really, because it's online. So
Yeah, let me just ask Dr. Ahmad with MME, did you have a comment on this, or should
Yes, I have a comment on that one. MME is spending a lot of money, a lot of time to monitor, to evaluate, to analyze all the data, and this is our findings, whatever we have seen. And there is nothing to worry about the air quality. Unless you do the proper validation, proper processing according to US EPA. All of our equipment are reference to EPA. If it is not, we will not use it. EPA reference method, EPA reference methodologies we use in our ministry. Therefore, the accuracy of the measurements are almost very high. So we are confident on that one, the readings. But we are not ready on to release of this data to public because they will not understand. Therefore, we are using air quality index values, which is commonly used in the world. This is the point. Okay. And also, the MME is now in the process of installing 7 more stations, ambient air quality stations inside Qatar. On the other hand, MME also utilizes and also other station data like QP station data. We are monitoring. They are all connected to MME. So we see what are the QP station data recording. So it should not be the deficiency of the monitoring inside Qatar. We are controlling every monitoring stations.
Mm-hmm.
Thank you.
Very good. Dr. Bolland, did you have a comment on this? I thought you raised your hand. Did you or
yeah, I just want to. I would like to add that yeah. So Qatar applies the US EPA standard, but is far higher than the WHO guideline. So yeah, so it means we let's say Qatar fulfilled the US EPA, but from WHO
stringent.
It's over, yeah. So it's true. So WHO applies 4 times lower standard. So this is also a point.
Okay. So there is a question, I think, for Dr. Ahmad. I believe maybe for you, Dr. Ahmad, MME. Did you see long-term from 2014 to 18 trend of PM pollutants, particulate matter?
As I mentioned, that particulate is the main problem in this country. That's the only problem we have here. We don't have any ozone, we don't have any other pollutants in Qatar. Particulate, which is coming from the natural sources. As I said, natural windstorms, dust storms, periodically comes, and we know what time they will come. Now, this is the time of subtropical jet to come to our region, Arabian Peninsula, and it will stay 5 months. So you should be aware that 5 months you might get any time this dust storm events. After the end of April, then this storm will go and the air becomes clean and like this.
Okay, Dr. Ahmad,
one has to understand that physical mechanisms to form the air particulate. Again, 3 mechanisms we are observing, and we are in contact with the meteorology department. Before we get our validation, we also check the dust storms event from the meteorology confirmed from our data. Then we do our validation process, and which is required by US EPA. We cannot release the data without validating data, but without getting the data from the instrument, and we say this is the values. This is not true. Like last time, EPA person came from California. They visit us, and I raised one question regarding the forest fires in California. Are you including this effect of these forest fires in your data? He says no, because they are considered unusual weather events. So we eliminate this data from our system.
So while I have you, Dr. Ahmed, you know, in your presentation, you mentioned that nitrogen dioxide and carbon monoxide are mainly due to fuel combustion from vehicles.
Traffic emission.
Do you recommend carrying out an automotive study to investigate the automotive emissions in Qatar, or maybe it's already been done, or what?
This was our recommendation to the government. Immediately, we should start conducting the automotive emission study to see. Actually, we should have done it before the rail system operated, the bus system operated, so that we could see the effect of this systems, you know, public systems. But now it is, but we can still conduct.
Okay, we are kind of, you know, getting almost close to the end of our allotted time. Just one more question, perhaps. Dr. Costa, you mentioned, as I understand it, at some point you implied that the dust events are not driven by regional events, but by local sources have also significant contribution. What does this mean for the residents of Qatar, and how can such a challenge be addressed by policies?
No, we said that the dust events are prominent in all Middle East and North Africa. This we know it's not something new, and it's attributed, as the Minister of Environment said, in the meteorological parameters. What we said is that the local component is probably equally important to the dust regional events. We have bare land in Qatar. We have a lot of construction activities. We have a lot of dust deposited on the streets. All of this contribute probably more to the local air quality issue. And we saw this with chemical analysis. We saw this with modeling studies and measuring studies. So we are pretty confident that our results are correct, and we have published this as well. What does it mean is actually that with policy and strategic plan, air quality can actually go better. And then our only challenge will be secondary pollutants that come from outside Qatar and the dust events. But we have a lot of things that we can do also for within Qatar.
Okay.
I have one comment here. MME took the initiative to install high volume air samplers for PM10, PM2.5, PM1. All analyzer samplers is installed in our monitoring stations. But however, our contractor failed to measure the particulates so far. But when they measure it, we will do the chemical analysis using the ICP. We have already purchased ICP in our laboratory. When we collect the filters, then we will know the exact amount of how much natural pollutants are there, how much anthropogenic emissions are there.
Dr. Ahmed, both us, Dr. Bolland, and Minister of Public Health have done already chemical categorizations, and probably you can also use this to get an idea until your stations are working. As I said, both us, Qatar University, Dr. Bolland is here, and Minister of Public Health, the respective department, have completed our chemical characterizations.
We will do this as regulatory activities, so that each station we will conduct the high particulate sampling with high volume air samplers and do the chemical analysis. This is part of our work now. This is our strategy, and we will also purchase the XRF, X-ray device, to monitor the particulate concentrations automatically, immediately.
Dr. Ahmed, Dr. Ali, very quickly, if you allow me. I think as we can see, the PM issue is paramount. It's really prevailing over our discussion. And, you know, the PM does, of course, at first, it affects health. But also, it affects also, you know, that renewable energy. So, again, health really indirectly, because we found out that the efficiency of PV, you know, the photovoltaic stations, solar energy, is affected tremendously by the dust. due to soiling, etc. So really, this issue of dust and soiling and is critical really for in major segments like health, renewable energy, and so on. So I think this probably needs more effort and more joining hands. And I think with this forum, with these really key players, I think we can have a synergy really where we can really put forward kind of legislation, because we need also to control or monitor the construction works going on in Doha. Also the pollutants coming from the industry as well. So we are looking, personally, I'm looking to have kind of regulation or legislation toward that.
I have one more comment on this issue. MME conducted a pilot study regarding particulate monitoring with the Japanese companies, okay, and the results show that more than 85% of air particulate consists of natural origins. More than 85, not anthropogenic, only 15%. But this doesn't mean that 15% is anthropogenic. So it needs further study to conclude. Therefore, we decided to purchase and install our high-volume air particulate samplers in our stations to get second measurement.
Okay. Well, very good. Well, listen, this is really a very, thank you for the very lively and spirited discussion on, I'm sorry that we didn't get to all of the questions. There is one outstanding question that, several people have asked and commented, that whether these presentations, would be available. I have to get with our public relation and IT department, and also to get the consent of the speakers to see if they want to release, their presentation. And if they do, then, perhaps our IT department can assist with that.
The recording of the session will be available tomorrow on the QNRF YouTube channel.
Okay. Okay, so there is a YouTube channel, and, go from there. So, well, listen, thank you very much. This has really been great. I apologize, again, for the technical issues that we had to improvise. It's kind of amazing. We did the, test all of the equipments, days before, and we tested the, all of the machines and sound and everything, and still, we have, it's kind of amazing that, we found very quickly a solution for the vaccine for the pandemic, but still we are struggling, trying to, debug, when it comes to these IT issues after all of these years. So I apologize, again, to the audience, to the speakers, for that. And but I'm glad everybody was able to be with us, and really great presentation, great effort. I know, these things really take a lot of effort and time and energy to put together. So we, on behalf of QNRF, I'm really grateful, for your contribution, and I wish you the best of luck. My apologies, to the participants, if we didn't get to your questions, and so hopefully, we'll have future Ross seminar on this subject and other environmental subject, which, the announcement, will be available, through the QNRF websites, and so you can frequently check on that. So if there is no other comments, we'll conclude. I think, we are just a few minutes over time, so I don't want to, keep everybody hanging there. And so thank you again, and have a good week. Stay safe, and, breathe normally.
Thank you.
Thank you very much.
Thank you. Goodbye.
Thank you.
Thank you all. Bye.
Keep in touch. Bye.
Okay, yes. Please. Thank you, Sheikh Abdullah. Thank you.